Hello everyone, good morning. We are here to present a paper on the big data ecosystem at LinkedIn. Myself, Saran. So what this paper is talking about is LinkedIn's Hadoop-based analytics stack. And who are the targeted users for this paper are machine learning researchers and data scientists. And how it helps them? It helps them in extracting insights from the data and also to build product features. And what is the unique solution that this application is offering? Is easy ingress and egress and also to manage production workflows. So what I meant by ingress is nothing but the data coming into the system, and egress is nothing but data being sent out of the system. And what is the key characteristic of this paper is all the distributed concerns are completely hidden from the user. Okay, what led to creation of such application? As we know, data is being increasing abundance, and till today it is like zettabytes or petabytes of data, and also the availability and affordability of large scale systems. This has led into the conversion of machine learning and data applications into a core production process. So some of the examples are of collaborative filtering. For example, if you see in Amazon, you buy an item and you will see that some other items are being recommended for you. These are nothing but all the data mining and machine learning algorithms which are running on the background and giving you all the data. So how these applications are created? These applications are built on top of Hadoop, and some of the advantages of Hadoop are horizontal scalability, multi-tenancy, fault tolerance, and easy to program. And it also has rich and active ecosystem. So part of Hadoop framework we can consider as Pig, Hive, and Mahout. Pig is nothing but it's a high-level data flow language. Hive, it's a dialect of SQL, and Mahout is nothing but all the machine learning language primitives. Okay, so among these advantages, the one that this application is mostly concerned about is easy to program. We knew that all the machine learning researchers and data analysts might not have good software background, and also they might not have knowledge on distributed concerns. Because of this ease of programming in Pig, they can directly easily develop their applications and also write code for the prediction system that they have developed. What is the advantage of this? All the development costs will be reduced and knowledge transfer can also be minimized. So what is the issue that is faced by data scientists and machine learners? They can develop their application in Hadoop using the Pig language, but the main concern that they have is how do they deploy the data? How do they productionize the data? This is the main solution that this paper is trying to answer. And how this application is solving this issue is it creates an environment where complete, structured, and documented data is available, and also the results of this algorithm can be easily obtained and published. And the key characteristics of this application is it's a large-scale, multi-data center deployment is everything written in a single line. So ingress. As I said, the data comes from online systems into our production system using an application called Kafka. This is nothing but a publish and subscribe system of a LinkedIn. So how the data integrity is achieved in Kafka? There is a stringent schema validation happening, and also some additional checks happens on the Kafka which ensures that data integrity has been properly happened. So workflows. Once the data enters into the system, the application creates a lot of workflows, and these workflows are being created and maintained by an application called Azkaban. Egress. So data has been entered into the system, workflows have been created, all the jobs are executed. So here comes the part of sending the data into the online systems. That is achieved through egress. And the three means of transport are key value access, stream-oriented access, multidimensional or OLAP access. So key value access, this is a primary mechanism that is being used by almost 70% of the applications. Here the algorithm delivers the results in the form of key value pairs, and all this data will be sent into database which actually performs in the key value store, and from here Voldemort, it's a part of Hadoop framework, it creates data and index files. Stream-oriented access. This is the second transport mechanism which is used by almost 20% of the applications. Here the results of the algorithms are in the form of log stream. Here the application developer will use this log stream and create the data into proper data structures that he wants. Multidimensional or OLAP access. Here the output is in the form of descriptive statistical application. and the output that it feeds in the form of front-end dashboards, and all the roll-ups and drill downs can be performed on this multidimensional data. So now I will be briefly explaining you the pipeline of the system. And before going to tell that, this application uses HDFS as a storage system. So you see two kinds of data enter into HDFS. One is from your database, example of Oracle here. The other comes from the online systems, that is called as activity data. So what is activity data? Any event, any triggering event that action or user performs is stored in the form of an activity data, and the database data is nothing but that is coming from your any database like Oracle. These activity data, which in the form of events, is stored into the form of semantic topics. These semantic topics are entered into the system using Kafka, and from Kafka this is stored into HDFS in the form of directories. So once the data enters into HDFS directories, and an ETL instance of Hadoop triggers and it creates two separate events, one for production and other for development. So that is why you see here there are two instances, one for development and other for production. Okay, data has entered into your application using Kafka. Now here comes the job of creating workflows. Workflow is nothing but it's a set of jobs that is being created by a data analyst or machine learning researcher to perform some tasks in order to convert into a derived data set. Okay, what is a job and what does Azkaban does? Azkaban is nothing but a workflow scheduler. It creates the jobs that has been specified by a data scientist, and it also manages the workflows. It also ensures the dependencies between workflows. So any job that Azkaban has been written will be of different forms, say MapReduce, Pig, Hive, and the default MapReduce jobs and the Hadoop's top type is Pig. Okay, data enter into the Azkaban. Azkaban has created multiple jobs for you. And how does a job looks? Job nothing but it's a configuration file. In the configuration file, the name of the job and also the name, all the dependencies of the jobs will be written to the particular configuration file. And from here, the data will be sent into the online systems back using the Kafka. Thank you. And from here, Harish will be explaining you the ingress.